morning again from my side. Can you see my screen?
Yes, we can see it.
Perfect. Thank you for joining today's webinar regarding the industry 4.0 and 5.0. My name is George Lachos from Core IC, and I'll guide you through the evolution, key features, and future path of industrial transformation, while I define the industrial metaverse. Feel free to interrupt me anytime if something is not clear. Let's frame our discussion by identifying the key characteristics and differences between Industry 4.0 and 5.0. To do so, it's useful to take a quick look back and overview the progress of industrial revolution. We have Industry 1.0, which took place in 18th and 19th century, and introduced mechanization through water and steam power. Then we have Industry 2.0 that occurred in late 19th and the early of 20th century, which brought mass production driven by electricity and the assembly line. Afterwards, we have Industry 3.0, which started and finished in the 20th century and saw the introduction of computers and automation. And then we arrive at the Industry 4.0, the current phase, where machines have become smart and connected. At the core of Industry 4.0 is the fusion of cyber-physical systems, the Internet of Things, and cloud computing. This has enabled machines to collect, share, and act on data, fundamentally changing how produce and operate. Key features include interconnected systems, real-time data processing, and a strong focus on boosting both efficiency and productivity. The backbone of Industry 4.0 includes Internet of Things for smart connectivity, AI for intelligent decision-making, cloud computing for flexible infrastructure, big data analytics to extract insights, and cyber-physical systems that bridge the digital and physical worlds. These technologies drive innovations like smart factories, digital twins, which represent virtual replicas of physical systems, predictive maintenance, additive manufacturing, and even autonomous vehicles. For example, BMW's iFactory strategy leverages digital twins to optimize every production site. Tesla uses AI extensively in its manufacturing processes, and companies like Lamasoft are predicting demand using advanced machine learning. So what's next? That's where Industry 5.0 enters the discussion. Industry 5.0 reintroduces the human touch. It's about using technology with people, not just replace them. It values creativity, resilience, and sustainability alongside productivity. This new phase prioritizes a human-centric approach, ethical and sustainable production, innovation through human creativity, and meaningful collaboration between people and intelligent systems. Some applications include advanced human-machine interaction through extended reality, which includes virtual reality, augmented reality, and mixed reality. For instance, AR can project live maintenance instruction onto a machine as a technician works on it, reducing errors and training time. Smart factories, which not only automate processes but also allow for real-time human oversight and decision making that helps rather than replaces human insight. Also, cobots or collaborative robots, uh, that work alongside human. Let's bring some of these ideas to life with real case studies. The one great example is in the healthcare, specifically in the area of robot-assisted surgery. You might have heard of the Da Vinci surgical system. It's a perfect case of human-machine collaboration. Surgeons use this system to perform incredibly precise operations, but they are not replaced by the machine. They are they are in full control. The robot enhances the surgeon's natural hand movements, filters out tremors, and gives them a much more detailed side, we can say. Another great example comes from Schneider Electric and their smart factory in France. They have integrated collaborative robots, real-time energy monitoring, and digital twin technology. So how do the two compare? Industry 4.0 is about automation and digital efficiency, while Industry 5.0 adds personalization, human creativity, and sustainable values. Bridging these eras means creating environments where digital and human elements work seamlessly. That's where immersive tools like the industrial metaverse come in. So this virtual environment mirrors real-world industrial systems, allowing simulations, training, and decision-making to happen in real time. AI and machine learning remain foundational to both industries 4.0 and 5.0. While manufacturing leads in adopting these changes, more traditional industries face challenges due to older infrastructure. Strategic planning is critical for successful integration. In summary, we are moving from smart automation toward the truly collaborative future. That's all from me. Are there any questions? If not, I'm passing to Athanasios. Thank you so much for your time.
Yes. Hello. Um, Actually, Euros, how would you like us to do this? Since now you are in charge of the presentation, so either I can share my screen and continue from there, or you can give me rights maybe to your presentation. I don't know if this is possible. Mm. Euros? Yeah, okay, that's better.
Sorry.
It's fine. I'm going to share my screen, just for me to have like full control. Um, Can you see now the screen or the presentation mode? Because I also have like two different screens here.
Yes, yes.
Uh, you can only see the PowerPoint that says digital transformation and sustainability, right?
Yes, Taros.
Okay, that's good. because I'm gonna be looking at this screen because right now the presentation is here. So if you see my head like leaning towards on the left, just you know that I'm looking at the presentation. In this continuation, we will mainly focus on digital transformation and how this is linked to sustainability. We already discussed yesterday up to a point the benefits that METAWAVE project brings in terms of sustainability as well. And of course, there is a link there because there are also a lot of different work packages in the METAWAVE project that also include the part of digital twins and optimization and digital transformation of the process. So there are like some interlinks, but today it's going to be a bit more general. And we will also start from Industry 4.0 going through Industry 5.0. So in this part of the presentation, we will see how digital transformation is fully linked with Industry 4.0 and how it paves the way towards Industry 4.0. But also we will see how Industry 5.0 integrates environmental sustainability with the innovative power of automation, ensuring that businesses not only achieve economic efficiency that Industry 4.0 brings, but also contribute to more sustainable processing. Digital transformation and transition to Industry 4.0 impacts different aspects of the industrial production in terms of supply chain, in terms of the energy consumption during processing, in terms of the quality of the product, and also in terms of the equipment. And we will try to make the bridge now on how this benefits and these changes that Industry 4.0 comes along with can also favor sustainability. We start with the energy consumption. One of the most important ways digital transformation contributes to sustainability is by improving also how energy is being consumed and managed in the industrial settings. We already discussed yesterday and the day before on the energy benefits that we expect from METAWAVE, and part of them is also linked, of course, to the Industry 4.0 digitalization. For example, real-time energy monitoring, where we could track exactly how much energy is being used at every point in the production line. And this on-the-spot visibility allows to identify the inefficiencies in the areas of excessive consumption and decrease the energy requirements of the whole process. Also, the AI-driven energy optimization take it a step further and use the data to make smart decisions automatically. For example, adjusting like the heating or like the cooling the machinery operations based on real-time demand. And that would, of course, also reduce the energy waste without needing the human and the manual intervention. Then we have the digital twins to increase the efficiency and the productivity. These are virtual models. They would allow us to simulate production processes and energy and mass flows without actually running demo industrial scale. And by testing these different scenarios digitally, industries can find easily the most energy efficient ways to run their operations before actually proceeding on investing or like making changes in the real world and real world processing. Also, when it comes to the energy consumption, this can also be linked with the prevention of breakdowns and equipment halting, because unexpected stops or maintenances can always occur in processing, especially when it comes to highly energy demand processes. And these disruptions could be avoided with predictive maintenance enabled by the digital tools that come along with Industry 4.0. And finally, automated and adaptive energy systems this is the part where these kind of systems can respond to the production needs. If production slows down, the system can automatically reduce energy used in that area, or like and vice versa. Or if the pricing, for example, of the electricity is lower at a specific point, or like if the renewable energy integration at a specific point is higher, you can always automatically adjust depending on your needs. So all these innovations, we could expect that they help significantly the energy consumption and consequently, of course, cut emissions because these two are interlinked.
Thano, sorry to interrupt, but we see the first slide only. I don't know if I'm the
Really?
only one.
Okay.
Yes, I see the first slide, digital transformation and sustainability. I don't know for
Now
the
I
others,
moved
but
already like 2 slides. Yeah, I don't know. It says, please move this window away from. Okay. Then I'm going to give it another try. Thank you, Katerina, by the way, because that would be a long presentation with only one slide.
this is true.
Yeah, in general, I don't use like the Zoom, so sometimes if I share this screen, probably it would be better. It would be better. And now you can see the presentation mode, I guess.
Yes,
Yes, but it's just
energy
on the presenter
consumption.
mode.
Yeah. I'm gonna do this.
Okay.
What about now? Now you can see the whole screen.
No,
No, not yet.
You can still see only the presenter mode.
yes.
Sorry for this, by the way. Let's see PowerPoint. Okay, it's enough. Sorry, but which screen I'm sharing now?
Digital transformation sustainability.
But is it like the whole presentation, or is just like again the presentation mode?
It's not full screen.
It's just a PowerPoint that we're seeing now.
But if it's like
If you share your screen in general and not the specific PowerPoint,
yeah, this is like because I have two screens. I wonder which one of the three is going to share. Which screen are you seeing now?
The third slide.
Yeah, but is it like the full slide? Because if it is the full slide, then we're good to go.
Presenter mode now. Yeah, now we're seeing the full screen.
now it's the full slide, yes.
Okay. Okay. So I'm going to continue from where I left. Now you can see the slide which says energy consumption and only that, right?
Yes, that's right.
Okay. Yeah. So We were in Industry 4.0 and how this is linked with sustainability, and we touched upon the part of how the reduction in energy consumption can lead to significant sustainability benefits. And now we move from energy consumption to product quality. This is another part where we know that improving product quality is one of the results of the digitalization and Industry 4.0, but it's not just about making better products when we talk about product quality. It also it would support like the sustainability as well. So this is what we're trying now to do in this presentation, make the links with the different benefits that come along with sustainability. So there would be like a direct link between sustainability by reducing waste, minimizing resource use, and extending the product life cycles by increasing the product quality. For example, with real-time monitoring, the manufacturers could assess the quality as it's being produced, and that would allow for immediate corrections, and that would also lead, for example, to waste reduction. As well, the digital twins and the simulations provide another advantage. As we said before, before anything is physically produced, manufacturers could run virtual tests, optimize every part of every part of the production process, and that would ensure a higher quality output right from the start, lowering the chance of having to run the process again and increase, for example, the usage of the materials and the increase of wastes. Finally, automated process control would allow for continuous quality assurance, and that would, of course, like also minimize the human intervention. These would be the systems that could adapt instantly in terms of if they would detect a deviation in process parameters, reducing the likelihood of defective batches and increased waste. So altogether, these tools could not only raise the quality standards of the products, which is, let's say, the immediate result, but they could also contribute directly to more sustainable production through reduced materials usage. Now we move to the equipment and how the Industry 4.0 benefits the usage of the equipment, and how this equipment better usage can consequently lead to sustainability benefits. Where like we already discussed about the predictive maintenance, which would avoid unnecessary part replacements and would reduce downtime, saving materials and energy. We could expect increased equipment lifespan, and that would once again lead to by keeping the machines in better condition and extending the lifespan, fewer replacements would mean less manufacturing of new equipment, reduced raw materials then, and also reduced emissions. Another major gain would come from the remote monitoring. If like operators can oversee all the performances and the machine performances without needing to be on site, that would allow for centralized management of different distributed facilities that all contribute to the much better operational efficiency and sustainability. And finally, we have also like the pretty self-evident bullet of reducing the wear and tear coming from human error, keeping like the optimal energy use and reduces unnecessary stress and maintenance on the machines. Finally, the impact of digitalization on the supply chain and how this is linked to sustainability. The AI and this digitalization changes is revolutionizing the supply chain management and could do that by enhancing how effectively and how agile it works. in terms of the planning and the decision making, we could use the predictive analytics to forecast the demand, optimize the production and the schedules, and respond to the disruptions in real time. And yeah, that would mean much better resource optimization, which could leverage also the machine learning to improve capacity management and labor allocation. Finally, with route optimization, real-time optimization of traffic, weather, and real-time conditions, we could ensure the fastest and most effective delivery routes, which could also by its turn reduce the CO2 footprint of transportation that is linked to the supply chain in the industry. And the final part of this presentation, because so far we were talking about Industry 4.0 standardization and how this is linked to and increase the environmental benefits and sustainability. For Industry 5.0, the work becomes easier because more sustainable processing is not just the result that is following the digital transformation like we saw for Industry 4.0, but now for Industry 5.0, this is a driver. So the sustainability is an actual driver of these changes. So now we do see that the Industry 5.0 is in the middle, and around it there is like the renewable energy integration, circular economies, eco-friendly practices, and the green supply chains. I'm going to start with the eco-friendly practices in the industry. Here, like we don't need like to think about how this is linked to sustainability. As we said, the eco-friendly practices in the industry would reset completely the way that we would expect that we would be manufacturing, making industries both sustainable and efficient with the energy efficient smart factories or zero waste manufacturing, where we could expect that products would be reused, recycled, and upcycled. And through this innovation, the waste would become a valuable feedstock or a valuable resource that would minimize completely the landfill impact. The water conservation is also very important. Advanced systems will track and reduce the water usage. We could reduce the wear and tear from human error, and this is something we also mentioned from the Industry 4.0, and also fully integrate the renewables into the processing, going towards the zero net emissions. The second part is the circular economy. That would be about like in Industry 5.0, completely rethinking how we create, use, and dispose of products. So the product life cycle would be fully extended. So instead of products ending up as waste, we would design them to last longer, and or being able to replace them, refurbish them, or repair them, essentially giving them a second life. And this is also linked to the second bullet, which is like the material recovery and recycling. The third slide is about the waste to resource innovation, which could be also one of the main pillars of circular economy. What was once considered and what is now considered like the waste could be a valuable resource, and that could completely transform the waste into a new material or energy. And finally, the decentralized and localized production, where it's needed, and that would reduce transportation, it would reduce cost, it would reduce emissions, and enable more efficient use of the local resources. The final slide, the final, let's say, pillar coming with Industry 5.0, that would be again a green supply chain, where we could have the AI-driven sustainable logistics, using AI, as we said, also for Industry 4.0 to optimize roads and reduce energy consumption and the CO2 footprint, low emission transportation, decentralized production, and finally localized on-demand manufacturing, which could allow us to produce the products exactly where we need them, and exactly in the quantities that we need them in order to reduce our production and the waste. This concludes the part of Industry 5.0 and also the part of how transitioning from Industry 4.0 to 5.0 is linked also to the significant sustainability benefits in the industry. Thank you very much for your attention, and sorry for the small technical issues with my multiple screen setup here.
Hi, thank you very much. Secret, the next section is yours, so please go ahead and share the screen and we can proceed.
All right, so just to check, am I sharing the right screen?
Mm.
All right. So today I'd like to discuss with you the skills for the future, essentially the skill sets that would be needed when transitioning towards Industry 4.0 and Industry 5.0. I'd like to start from a perspective of the digital transformation that companies go through when migrating to 4.0 and 5.0, and the skills that pop up in each of those stages. Now, a model that we typically use when discussing these kinds of transitions with companies is a model that was designed by the National Academy of Science and Engineering. I have a link later on in the presentation with the full book that they add to it. And essentially, in their model, they describe the transition the company goes through in multiple stages in creating value through digitization. Where in the first phase, you would have computerization and connected systems, so your essential digitalization, where afterwards in phases 3, 4, 5, and 6, in visibility, transparency, predictive capacity, adjustability, artificial intelligence and machine learning comes into play. Now, of course, this is mainly a 4.0 perspective. The model is also a few years old. So if we consider then transitioning towards 5.0, what you're actually adding to it is on top of primarily these higher level phases, the human centricity, the customization, and the sustainability. Now, if we walk through the journey, it would start off in phase 1 with computerization. Essentially, how do we digitize the data that comes out of our processes? And what this comes down to is just connecting whatever process you have to some kind of control system with sensors and actuators. So the most basic form of digitization. And what you try to focus on there is digitizing isolated processes and automating basic tasks where you would typically have your process automation specialists, control system operators, and so on. And we're talking about basic digital systems like PLCs and then some basic IT tools to replace manual tasks. But of course, as you're connecting it to some kind of computer, also professionals to set up the essential digital systems and supporting computerized operations. Now, if you take one step further, we're talking about connectivity. That's where we start networking different processes together. But rather than having isolated computerized systems, we connect them through network infrastructure. And this then, of course, extends the required skill set with network engineers and IoT specialists. And we're trying to connect the data together between different processes towards other systems. Of course, you also need some kind of system integrator role here that connects these different IT systems together, making sure that the data flow over that network runs smoothly. Now, this is, of course, just connecting machines and still automating basic tasks. We're not talking about artificial intelligence or really the 5.0 initiatives. It starts, of course, becoming interesting when we start dealing with the data that comes out of our systems. And the first step that a lot of companies take in a sense is creating digital twins of their systems. So a copy that can be either just a shadow copy of the data that comes out of the process towards full-blown simulation models that run in parallel with the system, on which they can then, in next stages, run more advanced analytics. And so the essence of this stage is capturing the real-time data across these different processes and building that digital model of the operations, where you typically would see then engineers with a background on sensor integration and data acquisition pop up. And of course, someone to develop then that digital twin technology, essentially engineers that create and manage these virtual replicas of the process and monitor it monitoring it in real time. Now, if we then go beyond just making everything visible in the digital twin, we end up with transparency. So essentially what we try to figure out in this phase is why certain things are happening in the process. And what we try to do is try to convert that raw data that comes out of the system into actionable insights and understanding process interactions. But of course here, roles of the data analyst and business intelligence professionals start playing a major role. We're transitioning here from complex data sets to clear insights in the process and really analyzing what is going on. And of course, with this insight, potentially also start thinking about process optimization, where then you would either have optimization experts or domain experts to interpret that data and try to drive the improvements based on root cause analysis of what they monitor in the digital twin environment. The next step up is then to go towards predictions, using then historical and real-time data from the digital twin to really try and forecast future events. And here, of course, the role of the data scientists or machine learning engineers becomes much more prominent, because analyzing that data and making predictions will allow us to spot trends, enable things like predictive maintenance, anomaly detection, and so on, and really try to improve the process using these insights and focusing then on optimization and prediction in order to streamline our process. And the final stage from the 4.0 perspective is then making everything adjustable. So essentially what we try to do here is to enable the system to autonomously react and adjust to the changing conditions, taking into account, for example, the data analysis and the predictions as well. Where, of course, you would have, on the one hand, automation and robotics engineers that can support the development of these autonomous systems. And, of course, also AI deployment specialists and people that focus on really the digital transformation, trying to oversee that continuous improvement and integration of advanced AI and automation systems, essentially closing the loop from the digital twin towards analysis and predictions, really back to the controller and take effective actions based on these insights and predictions. Now, if we then go towards Industry 5.0, we can build upon this entire stack. And what 5.0 essentially does, it adds an agile, people-centered, and sustainable layer on top of it. And so if we then focus on a human-centric aspect, some things that could be added in this phase would be, for example, augmented reality on top of digital twin for collaborative troubleshooting. We could provide contextual insights, really making the data transparent towards the end users and the operators. We could also adjust the predictions based on the experience of the user, try to give inputs to the models from experts, for example. And of course, in the act, make sure that it's not just a fully closed loop autonomous systems, but really a collaborative system where the end user could interact and essentially use that prediction and controls, automated control system as decision support. I think on top of it, with customization, again, we can, for example, use the digital twin for scenario modeling and simulation, at insights tailored to customer needs on the data analysis side, make personalized forecasts based on, say, the way of working of either an end user or the requirements of the customers. And also, again, make sure that the adjustments are not just something fixed, but really something that can be adapted based on the end user's needs. Similarly, for sustainability, we can also top up on top of this model by, for example, modeling energy flows, emissions, or waste generation in the digital twin. So really going from just measuring the process itself, try to add certain KPIs and metrics that are fully focused on sustainability. Because of course we can then again close that loop with the data science involved to integrate these environmental metrics in our analysis. Also try to forecast resource consumption and the environmental impact of our process. And then of course also automate the actions to prioritize, for example, energy efficiency and minimize waste. And take into account, for example, that when a process changes over time, so costs or of raw materials and so on, that we can dynamically adapt our process accordingly. Now, considering then the critical skills for this 5.0 perspective, if we summarize what we saw in the skill set for Industry 4.0, we were in this case looking at basic automation skills, process digitization, network systems, and I didn't really mention it, but of course implies that you also need some level of security when connecting systems together, for sure, if they're also connected to an external network. Primarily for the phases 1 and 2. Going higher up the stack, if we think about data capture, integration, real-time analytics, also people that can integrate sensors and also sort of visualize and process that data. And then the entire data modeling, AI, ML type profiles, system optimization, and of course people can actually deploy it. And then I'm thinking more about profiles that can deal with DevOps, MLOps, and continuous integration and continuous deployment. Transitioning then to such a system, of course, is not something that can just rely on a technical skill set. This applies to both a 4.0 and a 5.0 transition. You need a bunch of supporting roles that can actually help you deal with this kind of change. The first thing that's very important to consider is change management and transformation leadership. Because whenever you try to implement something in a company that is quite unfamiliar, new, maybe groundbreaking or completely changes the flow, you might get a lot of reluctance from the people that you're working at or that are working with these systems to adjust their way of working. It needs some kind of trust as well in that novel technology. So throughout that transition, you need someone to oversee that cultural change and make sure that all the different stakeholders, and this goes throughout the entire stack of the company, from people on the work floor towards higher management, make sure that communication throughout all these layers is clear and make sure that their concerns are also factored in, and that everyone gradually can ease into this process of transformation. Of course, whenever you deploy something, you can't just buy technology or develop technology and just assume that everything will just work out of the box. So you would, of course, have to set up this digital transformation project and make sure that whatever initiatives you set up, they're also monitored quite closely so that you can anticipate on potential risks. Also make sure, of course, that the timing and the budget and the impact are all factored in. So you would need someone that sort of has that holistic view to manage these projects as well. Of course, you can't just assume that any kind of innovation will just out of the box create some kind of benefit. You need to carefully factor in where the potential benefits and impact can be realized. So you would have some kind of person that does the strategic planning and also looks at the different business processes, essentially trying to map the current processes against future digital ambitions, factor out where that impact can be created, and set up a whole roadmap and strategy to go from that lower level digitization towards the higher level ones, making sure that the digital initiatives are in line with the business objectives and that the impact can, of course, be realized. Finally, and since it's a sort of holistic view, especially when we're dealing with Industry 5.0 and things like sustainability, we need to make sure that we can cover sort of that interdisciplinary collaboration, because we're working with people from different backgrounds, people with domain knowledge, people with more technical knowledge, strategists, and management, and so on. And so you would, of course, need to have someone that can communicate effectively and create this synergy between the technical and the non-technical teams in that sense. Now, switching back to the digital transformation in Industry 5.0 and the technical skills that are required here. Of course, the general data science and any kind of IT background that you would need for that 4.0 transition still applies, but Industry 5.0 might, for some of these topics, require more specialized skill sets. And when we're looking at the human centricity, essentially you need someone with the capability to create systems that can actually enhance human interaction and decision making in these industrial environments. So the first thing that could come to mind is someone with the experience in building user interfaces and actually figure out how people can effectively interact with these novel systems, making sure that the designs are ergonomic, user-friendly, and effectively empowering the operators, that it's something that everyone can work with. If you're then looking into the more advanced, like AR or mixed reality type applications, as I mentioned during that for that digital twin, you will of course need someone with a background in developing these kinds of systems as well. The rather specialized skill set for software development, but also someone that can deal with designing interfaces, for example, for these kinds of augmented reality type settings. And this could be very valuable if you want to have some kind of real-time support system for operators, for example, or a possible immersive training using that digital twin environment. And of course, when we're talking about decision support, we effectively have people interacting with these very advanced AI-driven systems. And of course, you would have someone that can turn whatever model, whatever data is available, or whatever insight is available into something that allows for very advanced user interaction. So it effectively need someone that can actually convert this complex data, possibly explainable AI models, into clear, actionable insights that can complement human judgment, but also set up a system that allows for this kind of human interaction, sort of making decisions together with the AI system and steering it in different directions as needed based on expert knowledge, for example. Looking at customization, this is about transforming the production systems to adapt rapidly to different needs of customers or end users. So what's a critical skill set there is to have sort of very agile product development in place and really thinking about how to design things. So you would have someone that is able to lead these kinds of initiatives to develop flexible modular production systems tailored to very specific market demand, so you can effectively set up this very dynamic system. Again, switching back into the digital twins, of course, here, if you need the digital twin to be very adaptable to whatever the end user needs, this would also require sort of a more advanced skill set to enhance digital twins to support this. And similarly, for the data scientists and AI engineers there, deploying a fixed model is one thing, creating models that are really adaptable, transferable, and that can be tailored to specific changing needs of the customer is also something that should be factored in during this transition. Finally, on the sustainability side, this is of course a skill set that you could just consider it numerically as this is additional KPIs to factor in, but if you really want to create a sustainable impact with your company, you need a much more holistic view on your entire process and way of working. And really embed these eco-friendly practices throughout your entire set of processes and production that you have at your company. Not just thinking about energy, but also thinking about the resources that are involved in the processes. And a key skill here is to have people with sort of the green process engineering mindset that are actually capable of developing production processes, for example, that can reduce energy usage and minimize waste. So it is really about sustainable optimization of processes, which is also often a multidisciplinary skill set because it can range from more software adaptations towards really changing hardware or the core fundamentals of the process itself. Thinking then about the sustainability, or at least assessing the impact of what your processes are doing, is someone that has the knowledge to really do environmental data analysis and really monitor and analyze the different metrics that you're pulling out of your digital twin and your predictions to do something with these actionable insights and look for opportunities for further operational improvement. And of course, since we're talking about waste management, is also thinking more about a whole ecosystem that potentially goes beyond the company itself and make sure that we can set up this kind of circular network around it. So try to design systems that enable recycling and reuse of materials, transforming linear processes into closed loop, sustainable operations, and so on, which could also, of course, involve different stakeholders, other companies that could potentially repurpose certain waste materials or possibly setting up collaborative systems that could further reduce your overall environmental impact. Now, looking then finally at the resources that you could use for this development and upskilling, I would highly advise you to go through the book on Industry 4.0, the Maturity Index, on which from which we borrowed the model that I explained with the 6 phases. Now it focuses primarily on Industry 4.0, but it's still very much relevant since a lot of companies are still in those initial phases of that digitization process. And it gives a much deeper insight in those 6 stages, but also gives some structural ideas on how to deal in this transformation with resources, information systems, organizational structure, and culture within an organization. And most of these ideas also translate nicely to Industry 5.0 transition. There's also some case studies and best practices there to benchmark progress and drive this continuous improvement. The link is here in the slides if you're interested. You can also easily find it through any search engine. And so what I would highly advise with the skills is first to really develop the digital foundation of Industry 4.0, making sure that you have already the core competences across these 6 maturity phases. And then with the people that you have, try to consider reskilling them towards that Industry 5.0 mindset, or find missing profiles if you still develop gaps. Now for Industry 4.0, there are some examples here for online courses that you could follow, for example, on digital transformation, or some general AI and data science courses that you could find online. There's a ton of resources available also from universities. There's a lot of advanced programs that you can find to do upskill profiles, a lot of lifelong learning trajectories as well. Now, if we then advance to Industry 5.0, you could then, for example, consider upskilling for a human perspective, human centricity perspective, and making sure that you can upskill people that focus on the operator support and decision making. For example, specializing in that human-computer interaction, or consider VR development. Again, a lot of examples from online courses, but again, there are many specialized programs available in higher education or lifelong learning as well. Similarly, for customization, it's about then making sure that whatever you design is also adaptable. There are a few nice resources available online, like how to develop these kinds of digital twins, which also considers then the adaptability of them, but also thinking for innovation in the Coursera course. And then finally, of course, on sustainability, there are some specialized courses, for example, in circular economy, but also on sustainable business strategy. So there's plenty of material out there that could be a good starting point for people that you would want to skill. This brings me to the end of my presentation. Some discussion points that you could consider when talking within your organization is, for example, try to assess what you think your current digital maturity is, using then that maturity index as a reference, and also considering then from those 6 phases where you're at on those 3 pillars of Industry 5.0. And maybe think about which specific initiatives you're already considering and which skills you would need in this case. Also, then, of course, it's always helpful to reflect on the initiatives that you had in the past and see what you learned from these transformations, try to identify potential pitfalls. As I mentioned, that change management is crucial when making these kinds of transformations in a company. So make sure to also check how the team is responding to the integration of these technologies, talk to the people on the work floor, talk to anyone up to the chain in management. And of course, consider what the biggest challenges are in integrating Industry 5.0 in your existing digital frameworks. And maybe you still need to work on that foundation of 4.0. Once you can make that transition, maybe check whether it's more of a technological challenge or whether it's about finding people with the right skill set. Maybe it's about upskilling people that you already have in your organization. Maybe it's finding external talent or other researchers, for example. And that brings me to the end of my presentation. If there are any further questions, I'm happy to answer them for you.
Great. Thank you very much, Siegfried. It was really nice. I think we can have the Q&A towards the end of the presentations if there are questions and discussion points. Next one is Tanya from Iman about integrating new technologies in daily operations. So, Tanya, whenever you're ready, please share your screen and proceed. Thank you.
Okay. Yeah. Can you see my screen?
Yes, Tanya.
Yes,
Okay.
yes.
Okay, I will talk about the integration of new technologies into the daily operation of the industry. Then the main objectives of this presentation will be talk about how the integration of new technologies should be, or what are the challenges in this topic. And specifically, we will go more in deep with the fiber optic sensors and multispectral vision cameras, that are the two technologies proposed from IMEM to the METAWAVE project. Then, why integrate new technologies in the daily operation of our industry? Well, the first is because of the revolution of the industry 4.0 and 5.0. But yeah, first, for the industry, the first point it will be improve the efficiency of the manufacturing, of the components, of the structures, wherever you will go to introduce the technologies. You will go to improve the efficiency of your operation. And the second is reduce the cost, because this technology, normally you integrate technologies for having a knowledge in your operation or in your component or structure, and have the advantage to make decisions, to take decisions before to something happen. Then you will go to reduce costs, because you will go to be able to do predictive maintenance. Also, you will go to enhance experience, because you will go to have more knowledge, or improve your knowledge about the operation or the component, and you will be to able to avoid errors or problems during your operation or your production. And you will go to have more the employees more happy, because they will go not have problems during the work. And also, all of these new technologies will go to give an advantage from your competitors, because you will go to have a production more efficient and more you will go to get more knowledge about your production and your operation, and you will go to have an advantage from your competitors. The steps for the technology adoption. The first is assess needs, identify the business or requirements. Also, select the technologies, because there are a lot of different technologies for different purpose, and sometimes you don't have the enough budget to select or to cover all the requirements that you have defined, but you will go to select the technologies that can cover the most of your critical points for your technology. Then you will have to sometimes develop or adapt some technologies to your requirements. If not, you can develop a strategy for the implementation of this technology in your company. This is the critical point because yes, sometimes the heads has a objective integrating the technology, but sometimes the employees has to suffer this integration and also the daily with this technology that sometimes you have to take this into account and make a great effort to train the employees to have a good success with your technology integration, because at the end your employees will be the ones that you will will be the will use the technology in the daily, and everything depends of them. And also fifth point are the most important, because it's, your work is not stopped when you integrate the technology. You will have to monitor the use of this technology and be sure that you are exploiting the whole potential of your technology, and checking that everything is going as it's supposed that it will be. Okay, then for the METAWAVE project, we will go to use fiber optic sensors and multispectral vision cameras for integrating these technologies for monitoring the microwave heating systems that will be developed in the project. The fiber optic sensors will be used for monitoring temperature and load, and the multispectral vision will be used for temperature and humidity monitoring. Okay, why adopt new monitoring technologies? Okay, then normally the traditional systems have limitations in efficiency and precision. Then you will need introduce new monitoring technologies to improve the capabilities of these traditional systems and avoid errors or problems. The fiber optic sensors and multispectral cameras will be able to give you real-time monitoring data, and they will go to give accuracy on the temperature monitoring. And the efficiency and optimization will be, these technologies will help to make energy efficient improvements in your industry. The challenges and solutions in the technology adoption is that the company or the employees or used to be resistant to the change, because they are working at the same way since many years, sometimes since the beginning of the starting of the company. Then they don't want to change the comfort way to work, and introduce new technologies, sometimes make some change that they don't want to make. The cost, because yes, you have a process, you have a company with some budget, and you have to change and assume a new cost for introducing this technology that is supposed that you will go to gain more money when these technologies will be totally implemented. The security and privacy sometimes are challenged, because some of the technologies, or the most of the technologies, used to work through this internet, and you will have to make some cyber security change, or introduce some cyber security issues in your company. And yeah, as I mentioned before, the integration of all of these technologies, all the requirements, all the trainings, all everything, sometimes is complex in a industry, and you should do in a gradual mode, in step by step, and with a secure path. Okay, the fiber optic sensors, I don't know if you know, but this technology is a silica cable, more or less, that is, it has a human hair size in diameter. Then they are very small sensors and very fragile because they are made on silica, but they have a high precision. They offer a high precision in their measurements. They are very sensible, and also they present immunity from true electromagnetic interference. That this is very important when we talk about microwave systems, but also for other process like welding or I don't know, but yeah, sometimes you need a sensor that will be immunity from the other electromagnetic waves. And this technology offers a distributed sensing, because you can go with the same fiber from kilometers of length, and you are measuring many points of the along this same fiber. In the case of the multispectral vision cameras, these cameras offer high precision and high accuracy in terms of thermographic measurements, because they use many bands of the spectrum, and then they will are able to avoid the hemicity errors, and you can select a lot of more convenient, and avoid the bands, the spectrum bands that you are not you have conflict with another components, or maybe with the dust or the humidity or other possible things that will be in your environment around the measurement seat. It's a technology that is a non-contact monitoring. That sometimes this is a key point, because sometimes you cannot touch the component, or maybe the component is in movement. Then these systems will be very useful for these applications. And apart from temperature, you can monitor or measure other multiple parameters like moisture, or even the composition. Sometimes these cameras are able to monitor the composition of some components, etc. Okay, regarding these technologies in the METAWAVE project, we have 3 industrial use cases. The first is ceramics, is Grèce Aragon, with manufacture some ceramic tiles. At this moment, the challenge that we have in this industrial use case is the high temperature consumption, and we will go to integrate a sensor for monitoring the temperature along the oven of this company, for monitoring the very high temperatures of the tiles during the production. And also, we will using microwaves for the heating of this process. The METAWAVE solution is a fiber optic sensor for monitoring temperature, and also multispectral cameras for also monitoring the temperature of these different steps of the tiles production. The benefits of these technologies for this specific industrial use case are the distributed monitoring, because we can use the fiber optic sensors to monitor along the hundreds of meters or along the small microwave system that we will go to use. And also we will go to use the camera for monitoring the gradient on the tile. And yeah, this is more or less all for this industry use case. The second industry use case is the asphalt in the asphalt sector, is for Copa company. The challenge here is that they have to heat the aggregates that they use for manufacturing the asphalt, and they spend a lot of energy to make this, because they have to reach 200 degrees, but with the actual system that they use, they have to heat more or use more temperature to reach this 200 degrees in the aggregate in a homogeneous way. The solution will be use a precise monitoring system to in the microwave system that we will go to heat these aggregates at the end of the METAWAVE. And the temperature, we will go to monitor here temperature by the fiber optic sensors and the multispectral systems, but also humidity with the multispectral vision systems. In the third industry use case, that is metalling, is in the carbon anode manufacturing. And the challenge here is also the high energy consumption that they have for manufacturing these carbon anodes. And in the METAWAVE project also will be developed a microwave-based system to heat and to manufacture these carbon anodes. And here the temperatures will be around 1,100, 1,300 degrees, and we will go to use only fiber optic sensor here to monitor the temperatures during the manufacturing of these carbon anodes. Okay, I put here some other applications that we have developed during the last years in different other European projects in research and in innovation actions. The first is the ACTIV project, where we use fiber optic sensors for monitoring HISA material. It's a high entropy superalloy material for coating the rollers that has ArcelorMittal in their oven. We embed directly by welding laser the fiber optic sensors in this during the manufacturing of this coating material, in the HESA material, and then we introduce this roller with a sensorized roller in the oven of the ArcelorMittal to monitor the behavior of this new material developed in the project. In the second case, we use the fiber optic sensors for monitoring the pipes of a geothermal emission, the geothermal plant, energy plant. And in this case, the objective was monitor the mass loss of the degradation or the degradation of this, the internal part of these pipes with the fiber optic sensors. In the third project that I mentioned here is the NISOL project, where we embed the sensors, the fiber optic sensors, in the different layers of a concrete tank for a thermal power plant. In this case, it was a novel tank because normally the tanks are made from metals, but in this case, it was made on a specific concrete developed in the project, and we embedded the sensors in the different layers to monitor the behavior of this tank, and also in the molten salts that will be inside this tank. The temperatures here were around 550 degrees, and it was very important to monitor the gradient of this big tank. And the last project that I will go to mention by where we use fiber optic sensors, it was for monitor beating of a ship. In this case, this component has a inner layer made of anti-friction material that is degraded with the operation of this bearing, and it is a very difficult component access. We propose it. You embed directly the fiber optic sensors by welding, and in this case by TIG welding in the anti-friction layer to monitor directly at the real time the degradation of this layer, and notify if something is going wrong. I have here also two more projects where we use multispectral systems. In the multiple project, these multispectral vision systems were used for monitoring temperature in a furnace. It's something like similar to the work that we will go to use to do in the METAWAVE project in the GRES use case, because these cameras were integrated directly in the furnace, and we use this technology for discrimination of steel lab and for thermographic, and for the composition to define the composition of these materials. In the Retina project, in this case, it was integrated and multispectral system, but also for LIDAR. And in this use case, it was for monitoring waves, and for determine the composition and the status of these grapes. This is more or less everything from my side. I hope that you understand a little better the problems when you introduce a new technologies, or the challenge when you introduce the novel technology in your industry.
Great. Thank you very much, Tanya. Right now we have an open Q&A session. If there are any other questions or comments from our audience, so this is the space and the time to do it. In the meantime, I will be sharing a screen with the webinar's 3 post survey, as with the previous 2 ones, so you can check it and do it at your own time. So let me share my screen. You're not seeing my screen, right?
Yes.
Okay, perfect. So you can either type down the link, or you can scan the QR code and go and have post-survey. So I don't know if there are any questions or points of discussion. I mean, Sigrid has raised some discussion points, Tanya as well, in their presentations, but the floor is open, so I will let you think. If you have to raise your hands and make some questions, please go ahead. I don't see anyone raising hands or having questions. I suppose you all had the time to scan the QR code or go to the link. So I think that concludes the series of our 3 webinars. Thank you very much, everyone, for the presentations and for attending them. The material will be uploaded into the folder on the SharePoint folder of the METAWAVE project, and then I don't know if we will be proceeding with disseminating further via website or things, but we will be in discussion with Crit regarding it. So that's all. Thank you from my side as well. It was nice hearing all these interesting presentations and all the points from our partners, and see you up into the next webinar series, which will be held in 1 year from now within different subjects and topics. Thank you very much and have a nice day.
Thank you very much.
Thank you. Bye-bye.